Hello, so this is the video for my final project for the quantitative methods and simulation. I choose to do the project of the stochastic matrices, so I'm going to start to run it. So I choose Python as a language because it was the language that I used in the whole semester. So the first of all, we have a little main that is going to give us a little menu that is not going to, well, it's going to be repeating in all the process, but if we put 9, it's not going to give some options. Unless we give the option 7, it's going to exit the program, but what it does is going to show us all the things that we can do in the program. So for example, we have two options. So we can create our own matrix, or we can create a random 3x3 already stochastic matrix. And for example, if we want to create a matrix, the values that we are going to need to input need to make an stochastic matrix, unless if the program is going to, well, otherwise the program is going to tell us that the matrix is invalid because the program only works with stochastic matrices. For example, I'm going to put a whole row so once, and that's going to give us the message: this program only works with stochastic matrices, so please insert another matrix. And it's going to give us that we don't have any metrics to work. So this time I'm going to give some values that are going to make an stochastic matrix, for example 0.1 and 0.9, another 0.1 and 0.9, and this makes an stochastic matrix because 0.1 plus 0.9 is going to equal 1, as well as the second row, and that makes it a stochastic matrix. For the other examples, I'm going to make use of the second option, that is to create a random 3x3 stochastic matrix. Well, I'm going to first explain how did I create the matrix and how did I check for a stochastic. So first of all, to make our matrix is like a very simple for loops, just to append all the values. To check if it is stochastic, I go through all the matrix, just checking. For example, for the first row, I check if the sum of the first row is going to be different from 1. If it is different from 1, I'm going to return a false. That is going to be checking the menu, and for example, the stochastic that is going to call the function is not true. That's going to print the program, and it's going to keep the matrix empty. Otherwise, it's going to print our matrix. So now we go to the second option, that is going to create a 3x3 stochastic matrix. So we choose that. It's going to print us a whole random but stochastic matrix. We did is, well, it's really simple. The only main part is the round range. It only gives us ints, so we need to keep dividing them. The random numbers, we need to divide them by 1000 to keep them in decimals. So what this little function does is that we generate a value that is going to be random. We put it in the sum, and we append it, well, already divided by 1000, so keep decimals. And now we like make a new range for the new random variable that is going to be, because as you can see, we go to n minus 1, so we're only going to, for example, in the is a 3x3, we're only going to be random. We're generating the first two numbers with another, well, making use of another range in each iteration, and the last number is going to be the sum minus 1000, because it's going to be the rest value that we need to make the row sum 1. So this is the way that we generate an stochastic matrix. The another function is going to be the long-term state. The only thing that we do is we use the NumPy library. We only use the np function to power the matrix into the 30. And so now we only print. We put to the 30 just to make sure that it's going to give us the long-term state. So we can see it is this one. We can also identify if the matrix is regular or not. The matrix is regular. How do we check if the matrix is regular? We have two functions. The first one is the one that is going to be called in the main. We only go to check from 1 to 8 in steps from 1. We are going to use this aux variable because we're going to check if the positive matrix of the MP matrix elevated to the value of the E for each iteration is going to be, all values are going to be positive. The way that we do this is we go to the whole metric, checking if all the values are bigger or equal to 0. If any value is less than 0 or equal to 0, it's going to return a false. So that's going to break the iteration, it's going to return a false. So in that way we can check in the main if that matrix is regular or not regular. The option 5 is going to be calculate the probability from going to one state to another in a number of x number of steps. Choose it. We need to choose how many steps do we want. So we have here, I'm going to say 3. So in each step, a step is going to print us the probability that is only going to be the matrix elevated to that power. And that's going to be the last functionality of the program. The other options are 6, just to print the matrix that we choose and to exit the program. Thank you very much.